So in this video, we're going to be talking about how do we factor polynomials. So let's kind of talk about what factoring means. So factoring just means we're going backwards in multiplication and trying to figure out, well, what two things multiplied or what two polynomials multiplied to give me this polynomial in the first place. So let's go ahead and talk about this first. Okay, so the first thing that we're looking for is if we can figure out the greatest common factor that we multiplied or that we distributed here. So that's what we're going to do first before we try to do anything else. Okay, so if you see these three terms, a 4, a 6, and another 6, you should think, well, okay, the greatest common factor between those three numbers is 2, because 2 can divide evenly into all three of those numbers. The other thing that we're going to want to undo is the negative. Our first term needs to usually be positive, so we're going to get rid of a negative 2 here. So it's going to be negative 2. Then you notice I have an x to the third, x squared, and x. So x divides evenly into all three of them. So we're going to divide a negative 2x out of here. And so what's remaining, it's basically what I get when I divide all three terms by negative 2x. So negative 4x to the third divided by negative 2x is going to be 2x squared. Again, I'm using my laws of exponents there. 6 divided by negative 2 is going to be negative 3. And then x squared divided by x is going to be x. And then negative 6x divided by negative 2x is going to be a positive 3. And then the x's just cancel out, so it's just a positive 3. And that's about it. So we're going to talk about how we would try to go ahead and factor this further in the next example. But for right now, this is the first thing that I would do. Basically, this is what I distributed to all three terms to get this term. So right now I have two factors, and the factors are negative 2x and 2x squared minus 3x plus 3. So the factors are a monomial and a trinomial. So this is kind of like before I would have given you an example like this to multiply through. And so now let's look at something a little bit more, just a little bit more interesting. So here I have a trinomial. The coefficient here would have been 1. The coefficient here would have been 12 and 32. There is no greatest common factor between these numbers because this is a 1. So there's nothing else that goes into 1 except 1. And taking out 1 from here wouldn't really do much. Okay, so what we're going to do is we're going to try to see, well, did I multiply two binomials to get this using FOIL? So last class we multiplied two binomials, and every single time we multiplied two binomials, for the most part, we got a trinomial unless the terms in the middle canceled. Okay, so what we're going to do is we're going to go backwards and with FOIL, and we're going to try to figure out, well, what did I multiply to get this trinomial? So the first thing that we do in FOIL is that we multiply the first two terms to get this first term. So there's only really one possibility. So what two things could I have multiplied to get k squared? Well, k and k. Now what we need to do is, our inner and our outer combine to get 12k. So we're just going to forget about that for a second. And we're going to skip all the way to our last, because our last two terms need to multiply to be 32. Well, what are my options to be 32? Well, I can multiply 1 and 32. I can multiply 2 and 16. I can multiply, so 3 doesn't give us a 32, so we can't do that. But we can multiply 4 times 8 to get 32. And then 5 doesn't go in to 32, neither does 6. And so that's about it. And then 7 doesn't go in. So these are my three options. We're going to start with the smaller numbers first, because 90% of the time that's going to work. If that doesn't work, then I would try 2 and 16. So let's try 4 and 8. Okay, so I have finished. So if I'm looking at FOIL, right, I have my first and I did my last. Now we have to figure out what would my outer and inner be, and is there any way that I can get a 12x with these numbers? Well, 4 times k is just 4k, and k times 8 is 8k. So that would be my inner and outer here in FOIL. And then what would the signs need to be for me to get a positive 12k? Well, if I add a 4k to a positive 8k, that will give me 12. So that means that the sign of this 4 needs to be positive, and the sign of this 8 also needs to be positive, so that they can both be positive and add up to be 12k. So that's about it. So I factor this. It factors into k plus 4 and k plus 8. And if I were to do FOIL, I would get the trinomial that I was looking for. So there are 2 factors here. I multiplied 2 numbers here, and the 2 factors that I multiplied are, let me just erase these check marks. The 2 factors that I multiplied are k plus 4 and k plus 8. Okay. Now let's look at this example. So remember in the first example that we did, with the first thing that we want to look at is there a greatest common factor that I can pull out first? Well, I have a -2, a 14, and a 16. So all these numbers are divisible by 2. Also, my first term is negative. I do not want my first term to be negative, because when I'm doing FOIL, I want to not have to worry about the sign of the first like I did here. I didn't really have to worry about is the k positive or negative. So we're going to take out a -2 from here. And so you're going to have a squared minus, so 14 divided by -2 is -7a, and 16 divided by -2 is -8. And so now we're going to go ahead and try to factor that trinomial into 2 binomials. And so in order to get a squared, we're going to do a and a. In order to get 8, well, there's multiple possibilities, right? I can either do 1 and 8, I can do 2 and 4. And that's about it. So let's try 2 and 4 first. Well, my inner would be 2a, and my outer would be 4a. There is no way to get a 7. If I add them both, I get 6. If I subtract them, I get a -2. So 2 and 4 don't work, and that's okay. That 2 and 4 are not going to be my last terms. All right, so this doesn't work. So let's try 1 and 8. So our inner would be 1a. Our outer would be 8a. I need a -7a. So that means that the bigger number needs to be, so technically, right, they would subtract to get 7, but the bigger number needs to be negative. The smaller number needs to be positive, so that they can combine to be a -7. So if I follow, we like to call this a smiley face method. So if I follow the smiley face here, the -8a is the one that's negative. So if I follow it, that means the -8 is negative, and the 1 needs to be positive. Okay, so the other thing that I always like to check is the sign of my last still good? 1 times -8, is that -8? Yes, it's good. It's perfect. I got this. So this works perfectly, and if I did FOIL, I would get this trinomial, and then if I distributed the -2, I would get exactly what I needed. So there are 3 factors here. My 3 factors are -2. Then the next factor is a plus 1, and the last factor here is a minus 8. Now let's suppose that this trinomial didn't factor, then we would say that it was prime, and then we would kind of leave it like this, sort of the way that we did in this first example, and we would just say that there was 2 factors, and that trinomial doesn't factor further, but it did. Okay, so now let's try this next example. Again, we're looking for our greatest common factor. So there's a -3x here, 12x squared here, and a -3x here. So for my coefficients, I can obviously see that 3 goes into it. I also want to take out this negative from the first term, so we're going to take out a negative 3. But then you have an x cubed, x squared, and an x. They're all divisible by x, so let's go ahead and take out the x as well. So now let's see what trinomial we're remaining with when we do this. Negative 3x cubed divided by negative 3x. Well, that's just going to be x squared. 12x squared divided by negative 3x, so that's just going to be negative 4x. And negative 3x divided by negative 3x is just positive 1. If you notice, all the signs changed when I took away that negative sign. They all kind of flipped. Okay, and then now we're going to try to see, does this trinomial factor any further? Can I factor into two binomials the way we did before? So negative 3x still remains. And so x times x is just x squared. And there's only one combination to get 1, which is 1 and 1. Now let's see, can I get a 4? This would be 1x and this would be 1x. Is there any way, could I add them? If I add them, I get 2x. If I subtract them, I get 0. So is there a way to get negative 4? Well, no, there is not. So this is the only way I can factor this. I can't factor that trinomial any further. We call that trinomial prime. So this trinomial is prime, and that's it. There's no way that I can factor. Prime just means that the only numbers that multiply to be itself in 1, so I can't do anything further with that. And then let's do our last example. This one's a little bit special, so you'll see why. So there's no greatest common factor here, but we can go ahead and try to factor this into two binomials. In order to get x squared, I'm going to do x and x. In order to get 1, there's only one possibility, 1 and 1. My inner is 1x. My outer is also 1x. If I put them together as both positives, right, I'll get a positive 2x. So my signs need to be plus and plus. So what do we notice about our two factors? Well, you should notice that they're exactly the same thing. So the way that we could write this is actually as x plus 1 squared. And if you remember this when we were doing this, right, forward, you remember that there was kind of like a rule to get this, right? The first term you would square it, the last term you would square it to get the last term, and then my middle term was going to be these two multiplied by 2. So x times 1 times 2 is just 2x. So you should have noticed that this was a perfect square trinomial. So how many factors do I have? So you got to be careful. There's actually just one factor. It just happens twice. So there's one factor, and the factor is x plus 1. I just want you guys to keep in mind that if you get the same two factors, we would condense it and put this squared on it, because that's what's happening. That's the way that we would simplify it. So this is the end of this video, and then I really hope you found this helpful and that you saw the connection with FOIL, and that we're just kind of doing it backwards. We're doing FOIL and we're doing distributing backwards.